So scientific measurements are reported in a very specific way. We report the measurements, we include all the digits that we are certain about, and then we always include one estimated digit. So the example here is looking at carbon monoxide concentration in Los Angeles County. And here we see these are in parts per million. This is 9.9. And over here, it's recorded to a different decimal place. It just says 10. So when we look at a measurement, we're going to assume that the last digit is uncertain. So here, there would be uncertainty in the tenths place. So 9.9, I understand that they mean it's 9.9, we're saying it's between 9.8 and 10. It's in that range. Over here, the last digit is the ones place. And so this is saying it's between 9 and 11. That's a much bigger range, right? So we're recording our digits to communicate to the reader how accurately, how precisely we know the number.
So which one was the right way?
Well, it depends. Which one's the right way? That's a great question. It depends on how it was measured. We can't tell just from that. But hopefully this will help us. So the number of digits that you record depends on the device that you're using. So here we're using a little kind of like a kitchen scale, and we've got a pistachio on there. And we're not going to talk about ounces because those are imperial units, those are English units, and this is science. We're going to use a metric system, so we're just going to look over here at the grams. But what we do here is we're going to look at what are the markings on this measuring device. What do those lines represent? And so we see that this top line is 0, and this one down here is 10, and in between there are 10 divisions. So each of these lines represents 1 gram, right? This one is 0, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grams. Each line is 1 gram. So when we look at this line, and you press on the scale, this moves up and down. This line is between 1 gram and 2 grams. You see that? It's literally between those lines. Is that going to represent 5 grams? No. It's between 1 and 2, right? So it's 1 point something. Is there any uncertainty or confusion about that? It's more than 1 and less than 2, right? So we know it's 1 point something. Now the point something we're not so sure about, right? So the point something we're going to look, and we're just going to kind of estimate between 1 and 2, how far do we think it is? Well, it looks like it's less than halfway, right? So you kind of imagine dividing that into 10 pieces. Is this going to be, are we all going to come up with the same number? No. It's an estimate. We're not saying this is what it is for sure. We're thinking this is our best guess. It's an estimate. So we might estimate this as 1.2 grams. It's clearly closer to the 1 than to the 2, but it's more than 1 and less than 2. So the 1 here, the 1 gram, there's no confusion about. Everybody's going to agree it's 1 gram and a little more. This last digit, the 0.2, that's the estimated part. Okay? Somebody else might have written 1.3 grams or 1.4 grams, and we're not going to argue about it. It's an estimate. Does anybody have any questions about that? So we call this reading between the lines. So those are the lines, the red lines. There's 1 gram and 2 gram, and we're literally reading between those lines. So another way to think of this is we're going to estimate 1 decimal place past the smallest division. So you look at the lines and you say, what does each line represent? Whether it has a specific number on it or not, just the smallest lines. So these were every 1 gram. It's the ones place. So we're going to estimate in the next decimal place. If we're using a ruler that has a line at each 0.1 centimeter, we're going to estimate in the next decimal place, the hundredths. A thermometer, the lines represent 1 degree. We're going to estimate the next decimal place. Does that make sense? A little bit? Let's practice. Because this is something we need to do for lab. So here's a blown up picture of a thermometer. And we can't see this, but it's degrees, it's Celsius, right? So this line represents 90, and this line represents 100. So each of these small lines represents what? 1. Okay? So that moved. The line equals 1. What's the next decimal place over? The tenths. So we're going to estimate 0.1. This is the ones place. That's where the lines are. And we're going to estimate the next one. So here's the red. It's not mercury, it's actually alcohol. And so we're going to look, well, where does that fall? Well, this is 100, 101, 102. It looks like it's 103. Might be a little higher. Might be right on 103. But it's clearly 103 something, right? So that's 103. And then we're going to estimate the next decimal place. And somebody might, look at that and say, well, I think it's right on 103. Well, how do we estimate that then? 0.0. So we write 0.0 degrees Celsius.
So if we don't put the 0.0, is that wrong?
Mm-hmm. Because if you write 103, so 103, a scientist looks at this and says, there's uncertainty in the last digit. So they only know it to the nearest 1 degree. So it's between 102 and 104. But that's not at all what we meant from here, right? There were lines for each degree, and so we can see it's really close to 103. So 103.0. You might write 103.1, 103.2. That is your opinion. Doesn't all have to be exactly the same. Okay? Let's look at this. This is a graduated cylinder. These are milliliters. When we measure the volume of a liquid, it forms this curve at the top. We'll learn in chapter 12, I think, why it does that. But that's called a meniscus. And we always measure the bottom of the meniscus. So that's right there. So first we look at this and say, well, this is 4, and that one's 5. So the smallest lines represent what? Tenths, right? So each line equals 0.1 milliliters. So then we're going to estimate to the next decimal place. Oops. So we're going to estimate 0.01. So this is 4. So it's 4. This would be 4.5. And that's 4.6. So it's more than 4.5, but less than 4.6.